Hello. So this is a lecture about sample problem from 151 to 160. Okay, so for this problem 151, the problem is we wanted to find the probability. Okay, so here totally we have 27 pieces of luggage. So from 27, we say like uh, we just pick a random sample of 4. So this means totally is we just from 27 pick 4. Okay. Okay. So we put the total 27. So pick 4. So we split 27 into 2 parts. So here some uh, some are insured, some are not insured, right? So we split there's insured or not insured. Okay, so we don't know how many are insured. So suppose insured we have like insured I insured and not insured is like here, so 27 minus I, right? Yeah. Okay, so we just split this into 2 parts, insured or not insured. We have 2 parts. So what is I? So I just we need determine from this condition. Okay, so let's say, uh, so we say like, so at the first check this like the probability that exact one of the damaged piece is insured is twice the probability that none of them damaged pieces are insured. So what is the condition? So there's a condition just like that. Let's say here. So from 27 pick 4. So here we want to find there's a probability, right? Exact one is insured. One damaged is insured. So we just insured. So here just equal like from like insured just we just pick 1, and then from other not insured pick 3. So this is just exactly 1 is insured. So this probability equal to twice of that 27 pick 4, and twice the probability, so twice of this probability, right? That none of the damaged pieces are insured. So all are not insured. So not insured is just from this pick 4. So from here we solve this equation. We find this I equal 8. So this means that for among 27, 8 are insured. Then then 15, 27 is minus 8, 15 not insured. So by now it's very easy to find there's a probability. Like there's a probability that exactly 2 of them are insured. So this equal just like that. Like we just pick. So here is from 27 pick 4 randomly. So here, so from this insured pick 2 and not insured. No, no, not insured. Oh, I'm sorry, 19, right? Not insured 19 from 2. Okay, so this is the answer. So for probability, for this problem 152, what we want to find? We want to find this probability that this guy examines few policies saying this guy. Okay, so number of this guy is less than the number, the few policies saying this guy. So let's say we let R means this the number this guy examined, and this T means the number policy this guy has examined. So what we want to find this probability of R less than T, right? Okay, so what is R? What is the distribution for this R? So R is number of this guy examined. Okay. Okay. So this guy just examines low risk policy and continue until a policy is found. So these are follow geometry distribution, right? So from here we can see this R follow geometry distribution. Okay, just continue until something happens. And stopped, right? Okay, so for T, so same procedure. Just only check a high risk. So this T is also geometry, right? Continue doing until something happens, right? Okay. So what is so for R? So I check a low risk. So R is, let's say, 10% probability of having a claim. So this means the probability that the claim something happen is 10. So this, let's say, here is 10%. Okay, and this is 20%, 0.2. So we can say like R and T, both of them follow geometry distribution with a probability P 0.1 and 0.2. Okay, so now we want to find this probability. So we said, so this problem just like that. So it's kind of problem. Like R follow geometry, T follow geometry. We want to find this. So for geometry distribution, we simplest way we can check like so we can check like based on the definition of geometry. The other way is we use the recursive method. This is usually for geometry. Recursion, this method is better. So let's check this. Okay, R less than, so R less than T. So R is first number. Let's say R, so T. So here, first time R find, T not find, right? So like R equal 1, so then T not equal 1, then R less than T. I'm sorry, I made a mistake. Like, yeah. So here, let's say R equal 1. Yeah, right. R equal 1, T not equal 1. Just like that. R equal 1, T. So T not equal 1. Then we guarantee this R is less than T, right? So what is such a probability? Such a probability is R equal 1 is 0.1. So we put this probability as P. Okay. So P, we have say P equal this case 0.1 multiply. So T is not equal 1. T not equal 1 is 0.2. So not equal 1 is 0.8. Right? Okay. So then plus so here just P, so T, this R not equal 1. R larger than 1. So first one not happen. We cannot determine. Then we just check stuff from like this first time happen, and this first time determined. Then first time cannot determined. So first time cannot determined is like what is the case cannot determine. So like first one R equal R happen or T happen. R equal 1, T equal 1, or R not equal 1 like this R first time this is not, this file is not claim, no claim, right? No claim first one, so T is no claim first one. So then they will continue. So then just start from second one. So second one and start from first one same. So just multiply P, right? Okay. So we just need to find. So what is the probability that so what is the probability for this? So for this one, what is the probability for this? For this one is 0.1 times 0.2. Okay, and for this one is 0.9 times 0.8. Oh, okay. Okay. So, but for this one, we need for this one. I'm sorry. For this one, meaning like R equal T. So here we want to find R less than T. So here just actually this R equal 1, T equal 1. So this is R equal T. So we should remove this part. Okay. Yeah. So we find the P satisfies this. P, this probability equal 0.1 times 0.8. So plus only this part 0.9 times 0.8 multiply P. Right? So we can find P. So we say typically this one removed, not include this. Yeah. So for this one, we want to find variance of y. Calculate the variance of y. We want to find Vy. So what is y? So let's say y means number of customer. Number of customer during the afternoon hour. Okay, and X is for morning hour. So also the number of customer. So during a certain time, how many people will come. So those things usually follow Poisson distribution. So this is like x and y are Poisson distributed, right? So for Poisson distribution, x for Poisson distribution, y also from Poisson distribution. So for Poisson distribution, suppose parameter lambda x follows as y also follow Poisson distribution, and the parameter is mu. Suppose okay. So here we want to find just the relationship between lambda and mu. So we just check those two conditions. First one, first moment of x is less than the first moment of y by 8. So this first moment means x, right? So x equal, we can say y minus 8, right? X is less than y by 8. So this x actually is lambda, right? So we change this as just, okay, this equation just equal lambda equal mu minus 8. So we get it, first equation is this. And then second moment. So second moment means like x squared. The second moment for x is 60% of second moment of y. So that's equal 6%, 0.6, 60% of y squared. Okay, so for Poisson distribution, we know this variance. Let's say for Poisson distribution, Vx equal also, like we cover this, like X equal lambda and Vx also equal lambda, right? So y equal mu and Vy also equal mu. So here what we want to find is find this mu, find Vy just mu, right? Okay. So here we changing this. We change this condition to equation. So here x squared equals 60% of y squared. So x squared. So what is x squared? So here we say x squared actually equal Vx. X squared actually plus Vx plus x squared, right? So because Vx equal x squared minus v square x. Yeah. So we know x squared equal lambda squared plus lambda. Okay. So here the same. So we have this equation. So mu plus mu squared. Okay. So we have two equations. This equation 1, equation 2. So we can solve for lambda and mu, right? So here we just focus on mu. So we just replace lambda by mu. So here replace lambda by mu. So finally we can get an equation about mu, and we get this. So then solve this equation. So we find mu, just solve it, equal 4 or 35. So but if mu, so mu should be larger than 8. So we find mu equals 35. So this is just a math problem, right? Okay. So for problem 154, what we want to find? We want to calculate the minimum number of those lead sections that make the chance of play winning less than 20%. Okay, so what is the chance the play winning? So winning is, let's say the problem says, like we have a square, so we put some, we have a square of a square board with area 1. So we just put some red, some blue. Okay, so like here, some red one, blue one. Okay. Okay, so let's say so the the area lead section, so is we have those area. Okay, so like here we have a big one is this, like r equal at first equal 1 is this, and then some r equal 2, so r equal 3, that. So other side is blue one. So when the chance this play can win, the play wins if the point is in blue section. So if we put it to red one, then this guy will lose. If we put it to blue one, he will win. So win means blue one. So blue one is less than 20%, means red one, means like those area of red one will be larger than 80%, right? Okay, so this means that those red one, total area for red one is larger than 80%. So here minimum number of sections, so we just put this section as large as possible. So we just pick R is as small as possible. So we want to find like 9/20. So I. So we just check I is from I equal 1 to some number. Right? So we just let this e larger than 80. So questions find. So questions, what is A? What is smallest A? So for such a problem, so we say we can add them up. So that this summation is, so actually this summation equal, we just say this one equal just 9/20 or 9/20 square plus, right, plus 9/28. So we can have a formula. So this equal 9/20. So here 1 minus 9/20. So here 1 minus 9/28. So we let this larger than 80. So we just check this A. Okay. So simplify this equal 20 minus 9. 20 minus 9, 11. Yeah. So that's equal like 9/11 times this. So we just check Okay, so n so n equal very large. This is true. So then we just check our n becomes smaller and smaller. So n equal 5 or 4. Just check this. Yeah. So which smallest n satisfies us? So for this problem, what we need to find, calculate the absolute value of difference. Just a minus b absolute value, just like that, between force moment of x and the force moment of y. So this just means we want to find this like x4 minus y4. We need to find this, right? Okay. So what is the x? What is the y? So x this x is claim amount divided by 1,000. So this claim, let's say we just put this claim, or we just put a. This claim is just for a uniform distribution between 1 to 10,000, right? Okay, so we can say x for a uniform between 0 to 10. So x is a uniform distribution. Okay, so how about y? This y, the part y. This y is this x belonged to nearest integer from 0 to 10. So let's say, so y, so x is just from 0 to 10. So y, so for here, 1, 2, like that, 9, 10. So this y is belonged to nearest integer. So let's say, so here the from 0 to 0.5, so here's 0. Then from like 1 to from 0.5 to 1.5 is 1. And then from here to here is 2, like that, right? And let's say, so from, let's say from 8.5, from 8.5, so if x from 8.5 to 9.5, this is 9. And from 9.5 to 10, this y become 10. Okay, so this is just like that, like x is x from 0 to 1, 0 to 10 is just equal this. So y is just cut this just 0, then here like cut from integer, just like that. So we want to find the difference. Okay. So here x4 is easy because this contains the x4. We just do some calculation here. X4 equal from 0 to 10, so x4 density function, so it's 1 over 10 dx. Okay, so this x4 very easy to calculate. Okay, so let's say equal so 10 5 over 5, right? So ex4 is very easy. So for ey4, So this calculation is a little bit tedious. So this one we have to separate piece by piece. So this one, we can put like okay. So from 0.5 to 1.5 is one interval. Then from 1.5 to 2.5, like that. So we use summation. Let's say like from k minus 0.5 to k plus 0.5. Then this y equal k, so y4 equal k4. Okay, and this probability is uniform, so 1/10 dx. And so this summation k equal 1 to 9. I cannot be 10, the 1 to 9, and then plus from 9.5 to 10. So plus from 9.5 to 10. So this k equal 10 4. K equal 10. Yeah. So then 1/4 dx. The 1/10 dx. So here we just need some calculation, and then like so this interval just like a constant. Yeah. So we just check those summations in just it involves some calculation. Yeah. Okay. So like let's say divide here. So this equal k4, right? So constant is multiply 1. So this interval integration just become 1. So here just become half. Yeah. So this maybe apply to here ey. So ey is 4 equal. So this equal just the summation. This k. So this equal k4/10. Yeah, just k4/10. k4/10. Then k from 1 to 9. Then plus, so here is 10 4/10, 10 3, so multiply half. Okay. Okay. So problem 156. So this one we have like just this is like 2 variable but discrete. So this is just a 2 variable discrete distribution. Okay. So the number of x, probability of x loss during year 1, loss year 1 during year 1, loss this during year 2, loss this. Okay. So the number of x loss. Okay. So this x and y means like how many time loss happen. So in year 1 or in year 2, let's here. In year 1 can happen 0, can happen 1, can happen 2, like that. And so here is giving x. So giving x loss in year 2. So this is not this is those are just a conditional distribution. Okay. So we want to find, let's say, so here. So this is a conditional giving x. So let's say like this is such a probability, right? We want this is the number of loss y equals sum. Giving x equals giving x, like that. So we want to find the probability that exact 2 loss in year 2. So this probability is, use this notation is just y equal to, right? Y equal to. So y is number of loss in year 2. So in year 2, oh, so here, understand, no. This should be careful. Let's see. In 2 year, not in year 2. Yeah, in 2 year. So this here, understand the issue. In 2 years, not in year 2. So in year 2 is y. So in 2 year means together, right? First year, second year. So let's see. This is wrong. So X stands for first year. So Y stands for second year, just like that. Yeah. So let's see. Yeah. Y is second year. Yeah. Okay. So together is 2. So we can have thus, right? Together is 2, just like, okay, here's 0, 2, 1, 1, 2, 0. We have those 3 cases. Okay. So what is this probability? The first case is, so this one is like, we want to find this x equals 0, y equal 2. So what is this probability? So this table is not give us join the distribution for x and y. This is so here's a conditional probability. So for this one, we just say, x equals 0. So this probability, we just like this is like we have to use conditional probability. Yes. So here just like this, just like those things, probability A and B like equal. So one fixed PA multiply just giving A, B. We should use those formula. Okay. So here let's say this equal x equals 0. Then under this condition, x equals 0, y equal 2. So here this probability x equals 0. So x equals 0. What is x equals 0? So x equals 0 is the probability x equals 0 is thus 0.5 x plus 1. So x equals 0, this is 0.51. So x equals 0 is just 0.5. So this 0 plus 1, just 1. So I just put a formula 0 plus 1. So here, okay, so then what is this probability? When x equals 0, y equals 2. So x equals 0, y equal 2 is thus 0.05. Okay, so 0.05. Okay, and for those, so what is the probability? 1 x equal 1, y equal 1. So we know, so we understand it. So plus, like x equal 1 is 0.5, 1 plus 1. Then check the probability that when x equal 1, y equal 1. Giving x equal 1, y equal 1. So giving x equal 1, giving x equal 1, y equal 1, thus, right? 0.30. Okay. So then plus x equal 2. So x equal 2 is 0.5. 2 plus 1. Then the probability that when x equal 2, y equals 0. X equal 2, y equals 0 is 0.25. Okay. 0.25. Okay. Okay. So for this problem, easy. Like at the first we need to find p such that x equal 2. So use the formula. What is x? So x equal x, just equal that's like x fx. So density function is this xp dx, right? And x from 1 to infinity. So we let this equal to. So we find p. We can solve for p. Find this p. P is constant, right? So here for integration, p minus 1 the p. So we can integrate it out. We find this equal this integration. I'm sorry. Yeah, this integrate out. This equal p minus 1 over p minus 2. Yeah, so we let this equal 2. So we find p equals 3. Oh, so we are done. This problem is easy, right? So this problem 155. So this is a mixed distribution. Some part is continuous, some part is discriminate. Yeah, some is discrete. Yeah, some are continuous. Okay, so we want to find x. So we need to find a density function. So this is a cumulative function. Okay, so from cumulative function, we want to find a density function. So density function, so we say find the density function. Okay. So from 0, so we can say at this point 0, it has some jump. Jump is 0.5. So we say, so here we have density functions when x equals 0. X equals 0, probability is 0.5. Okay. Okay. So when x from 0 to 2, this is here's 0, yeah, right. And then from 2 to 3, so this is it's a derivative, right? So from 3 to 2, the density, there's a probability jump from 0.5 to 1. So this derivative or the slope is let's say like here jump is from 0.5 to 1. So here's from 2 to 3. So this is 0.5. So this is point also constant, 0.5. Like this, right? Okay, so the x equals 0 multiplied probability 0.5. So plus from 2 to 3. So this x and multiply its density function 0.5. So dx. Okay, so this equal this is 0, and this is 0.5, just half, right? So x dx x integrate out, so half over 3 square minus 2 square, right? So for this problem, we want to find the probabilities we want to find probability x less than 3. So what is this x? So x be the absolute value of difference between the two number of dice. So we can say first die like so x equals s, right? D1 minus D2 absolute value. So this d less than x means we want to find x equal 0 and x equal 1 and x equal 2, right? So what is the case for x equals 0? So x equals 0 means d1 and equal d2, right? So d1 d2 like this. So like 1 1 2 2, right? 6 6. Okay. So okay. So x equals 0. How many such a chance? So totally is we say totally is d1 can 6 case, d2 also can 6 case. So the d1 equal d2 have 6 case, like 1 1 2 2, right? Okay, so x equal 1, so we just check it. Okay, then x equal 1, x equal 2 2, so x equal 1. So x equal 1 is, let's say, can be like 2 1 and 1 2, right? Yeah, we just multiplied 2 1 and 3 2, 4 3, 5 4, 6 5. So we have a 10 case. Yeah. So here we have 10 case for this, and then plus like x equal 2. So x equal 2 is like okay 3 1 and 4 2 5 3 6 4, right? So here we have 8 case. Okay. Let's see. Yeah, x equal 2. Okay. Yeah. Okay. So now let's say problem 160. So 160 is we want to find the variance of this. So variance for this Vm plus n. So we have this formula equal Vm plus Vn plus 2 times covariance of m n. So variance just a square. Just here just m plus n square, right? So equal n square m square plus n square plus 2mn. Yeah, so okay. So here we have Vm, Vn. So the only thing we need to find is covariance. So we just find this. So how can you find covariance? So it says their correlation is thus. So what is correlation? So we say correlation according to definitions. Correlation x y m n is thus equal covariance of m n over so variance of m squared variance of n squared. This is the definition for correlation. So this correlation is 0.64. So we can find covariance. Yeah, so this equal covariance just equal to, yeah, so 0.64. So time variance. So variance 1600 square root, yeah, and 900 square root. Okay. So this problem is easy. Okay. So those are problems from 151 to 160. Okay. So we can stop here.